And welcome everybody to the latest edition of the Diamond Anvil Too Hard to Smash. I just got back from bike riding and Eugene was ready to shoot a video. So, hey, let's do it. There's no time like the present, right? Why put off till later what you can do now? Eugene, thanks for joining us. Are you there, bud?
Yeah, sure. Hello, everyone. Thanks for having me.
Fantastic. Coming at you from Minsk, Belarus here. It's Eugene, and congratulations on your recent paper submission. So he's submitted a paper, folks, about solar flare anisotropy. The idea that there seems to be, well, we won't give it away at the moment, but we will discuss it here toward the end of this video. We're going to start out with some other stuff. We'll cover various topics. And so, Eugene, what's sort of the what's the basis for the paper? What led to the paper getting made in the first place? Our regular viewers, just a little background for those of you who aren't aware, our regular viewers probably have heard me talking about solar flare anisotropy for quite a while. The idea that based on the flare's location on the solar disk or on the limb, depending on where it's located, there may be some oddities in solar flare frequency, intensity, etc., right?
Yeah, so the motivation was this idea that's been circulating for a while, actually, of the so-called Earth-facing solar quiet. So that apparently, anecdotally, again, people notice that for some reason the sunspots kind of do seem to calm down when they're against the Earth. So when the sunspot is appearing, like it flares a lot. Then when it's at the center of the sun, like it suddenly stops flaring, and then as it departs, it starts flaring again. At least that's the anecdotal, evidence.
Gotcha.
So I decided to check it, essentially. So I took the statistics, took the flare lists, and I looked at where the solar flares actually happened. And I've only focused on the X flares, though,
So no M or C class flares. All right.
Yeah. There is one.
So basically, you cherry picked the data because you had an agenda, right?
Yeah, so to speak. There is a slight caveat.
I was just kidding,
to
folks. I was being sarcastic here, but Eugene and I both have dry senses of humor, so you may not have understood. I was just kidding there. I didn't really mean he actually cherry picked.
Yeah, so some of the higher end M flares are actually present in the list because I use the catalog that kind of overestimates the flux of the flare. But maybe you are actually unaware of this, but GOES, when they measure the flare flux, they actually artificially lower it with respect to what the detector is picking up. So what you see,
really?
when they say, the flux in this 1 to 8 angstrom channel, it's actually artificially lowered by NOAA by 42%. And they've been doing this for like 40 years already, or even more than that.
They lowered the flux by 42%. And
yes,
I'm sure there's got to be reasoning behind it.
Yeah, there probably is. I didn't look into details, but it's referenced in the paper. You can see the link.
Huh. Anyway,
yeah, the document of how they process the GOES data specifically.
And just since we're gonna get into a lot of nonsense in this video, we've got a list of topics that we're gonna cover, folks. But for very brief periods of time, this all sort of it's all gonna tie together here in a lot of different ways because a lot of the stuff that is on my list, and it's a hell of a list. Eugene has looked into before, so we're gonna shove a bunch of stuff into one video here. I'm sure it'll have quite a lot of interesting highlights. Before we do any of that, I just wanted to plug Eugene's channel. I was scrolling it here in the background here for a moment. Eugene the Philosopher. Check out his channel. Press like, subscribe, share, etc. Go check out his videos. He just recently put out one which is about this solar flare anisotropy situation, which is pretty interesting, and it might tell us something about heliophysics that most of your average astronomer types don't understand or know anything about, really. So it's, there are some advances about to happen in the realm of perhaps astrophysics, cosmology, heliophysics, the natural sciences in general as a result of this. So here's just a quick list about some of the stuff we're going to talk about, folks, because we want to compress a whole bunch of info into a whole short period of information. So again, congrats on your paper. which, by the way, is available now in preprint format. And we'll actually post a link to that in the description, as well as to Eugene's channel. So check that out again. Go subscribe over there. Check out his fascinating videos. We're going to be talking about, wait for it, flat Earth, chemtrails, electric universe / plasma cosmology, the end is near, cults in general, scientism, earthquakes, forecasting fails, planets and barycenter fails, and cosmology nonsense, all types of that, which is a lot of it, and heliophysics and flare anisotropy and heliophysics, which is cosmology and plausible cosmology, and maybe we'll even bring up my crap theory. And then we'll talk a little bit more about Eugene's paper toward the end of the video. So let's start out with, again, congrats on the paper. Anything as sort of a preface before we delve slightly deeper into it toward the end of the video?
Do you mean about the paper?
Yeah.
Well, I mean, I'm just happy that I've finally done it because, I mean, I've been complaining to you for like 2 months already.
Yeah, Eugene's been a dick for the last 60 days, so, you know, I'm just kidding. You were perfectly polite the whole time. So let's talk about flat Earth. What are some easy ways that you could convince people that the Earth is not flat? Let us know, theoretical particle physicist Eugene. I think this might be beneath your knowledge, but go for it.
I don't know, honestly. I mean, there's just so many pieces of evidence. Like, look how stars move. Look how the sun moves. Look at like the basic trigonometry. You know, like the sizes of the sun and the moon, like where they should be.
Yeah, these are good points. I mean, I always like to bring up the fact that the stars orbit the celestial pole star in opposite directions. Northern versus southern hemisphere. Lunar eclipses are always a good one. And what about a better plausible single theory to explain the seasons and day-night cycles? That might be a good place.
Oh, excuse me?
A single, because flat Earth lacks, the flat Earth enthusiasts, they lack a single theory to explain both the seasons and the day-night cycles with a single theory.
Yeah, well, I mean, it's just don't get me wrong. Like, I appreciate alternative ideas, but
yeah,
you know,
same here. But not ones that are moronic. Yeah.
I mean, not the ones that are kind of easily debunked if you just think about them for like 10 minutes.
Right. And by the way, these first couple, I sort of have these in the order of how idiotic I think they are. I think flat Earth is the dumbest and most low-hanging fruit of all, followed shortly by chemtrails. So, and just let's quickly define this term. When I say chemtrails, I mean a large-scale program using things like commercial airliners to intentionally spray various chemicals into the atmosphere for reasons unknown. All right, so just the large-scale program using the regular aircraft that you see from your basic contrails, that those are sinister. That's what I mean by chemtrails.
Mm-hmm.
So, Eugene, what do you think about that one? Do you think that there's a large-scale program to intentionally spray chemicals out of the multi-million-dollar engines of various commercial airliners and so on for whatever reason? I mean, there are various different motives. It's just that the whole thing lacks motive, opportunity, and means. That's the only beef I have with this alleged crime, is that it lacks motive, opportunity, and means. But otherwise, it's perfectly plausible.
Yeah, like, if I'm being completely honest, like, I have no idea. I mean, maybe, right?
Like
I
jet
do
fuel
know for
additives or something?
fact. I don't know. Again, like details. Like, I know nothing about the industry in the first place, so...
You're not a pilot. You don't have any friends who are pilots and stuff, right? Like,
I have a friend who actually works for like maintenance. He's like not an engineer even, but like, the supporting personnel. Like, he refuels the planes and stuff.
Okay. Does he see truckloads of chemicals being loaded onto planes instead of luggage?
No, I don't think so.
Yeah, I suspected so. Yeah, like, where are all these truckloads of chemicals? Where are the chemicals? Where are the planes flying in the stratosphere? Like, the arguments are so dumb, and they indicate that the people that are making the arguments don't understand the first thing about how the atmosphere works, how planes work, etc.
Mm-hmm. So one interesting thing is actually, like, again, maybe the viewers are not aware, is that when the plane lands, they actually like remove the static electricity from it, but before they refuel, because obviously if there's a spark,
Well,
things
because
could go.
they don't want the plane interacting with the universe, which is electric.
Yes, exactly, because everything is connected.
Yeah, right. The plane will become friends with the sun, and it could destroy the universe by opening a black hole opened by CERN.
It's quantum entanglement with
It's got to be
Andromeda.
quantum. Yes, anything that you can't explain must be quantum. Which brings
Yeah,
me
so
to our next thing: electric universe / plasma cosmology. They are kind of separate in a way, but they're both not. I don't know. How do you even? How would you define either of these terms? I have trouble defining either term.
there is a very good paper by Bob Johnson, which is exactly called like what's the difference between electric universe and plasma cosmology,
Okay.
and or like plasma universe. I think like electric universe versus plasma universe. Like what's the difference? And I'm gonna send it to you. It's really good. There have been a video of the same topic of him like basically giving a talk on it
Okay.
about the paper, but it has been taken down. I don't know why. Yeah, but the paper is still available.
So, like, I mean, like, the beef that I have with it is that there are some distinctions that are sort of shared, I guess, versus what you'd call mainstream astronomy. I hate to even use the word mainstream at this point.
Yeah,
Every term is so disastrously sabotaged by people who have no idea what the hell they're talking about. But
yeah,
my beef is that everything isn't fundamentally electric, and this is often met with, well, I'm not going to get into it, but it's just that I don't like.
Oh
Most
wait!
people that understand astronomy.
Sorry, I just found the video. It's actually
No,
up.
that's okay. Which video? There's a video explaining the difference.
The difference between the electric
All
universe
right,
and
we'll
plasma.
link that below this video also. Keep in mind,
Yeah,
folks, most of our content on the channel is live streamed. This video was recorded, so we will put that in the description as well. But in 30 seconds or less, can you sort of explain what electric universe and plasma cosmology are to people who've taken college astronomy and never heard of electric universe or plasma cosmology?
yeah. So the plasma cosmology is actually a sort of a decently developed field. It features people like Hannah Southvein working in it, and maybe Anthony Peratt and a couple of others. So it just underlines the importance of plasma processes like electromagnetism in the universe. Whereas the electric universe is a more sort of a conspiratorial, you might say, thing where they have a much more radical statements than, let's say, plasma universe.
It's more tied together to a bunch of esoteric spiritual nonsense too, like shapes are like, geometric patterns are sacred because reasons, dude, and like all this stuff. Like that's there. Like the electric universe seems to really sort of bridge the gap between why you've got a crystal around your neck and why everything's connected and electric. It's like, dude, if you can't measure it, you're not quantum entangled with it, or you can't prove you are. So either way, it isn't science. Enjoy that.
Yeah.
Right?
Well, to be fair, and like we shouldn't use science as like the ultimate, I don't know, criterion for whatever. Like a lot of things in our life are not scientific, and
no, I know, but that doesn't necessarily mean that they can't be explained, right? There's many things that can't be explained currently, but that doesn't mean that they're impossible to explain. Lack of evidence does not necessarily mean that there is no evidence available.
yeah, that's true. That's true.
I mean, that's part of what science is, right? Like a lot of the stuff that's probably going on that could explain all kinds of crazy mysteries of the universe is just happening right in front of our faces. We just don't know how to explain it with valid physics explanations, right?
Yeah.
By the way,
you got to remember that the physics is not really set in stone.
Oh, I know.
Like,
It's just a way to quantify things.
The theories evolve. Our perception of the world evolves with the theories.
By the way, Eugene, for all the Electric Universe people that are watching this video, you can see my screen, right? Check it out. There's, quote, gravitational lensing right there. That should make somebody mad and leave a comment. So we've made the video as inflammatory as possible. That is the Radio Galaxy Cygnus A there, by the way.
I cannot see your screen, just FYI.
Oh, all right. Oh, that's right. I forgot to put sharing on. All right, let me reshare here. Well, there's gravitational lensing going on in the background here, so that should make somebody mad, because if you say gravitational lensing, somebody will say that's fake, or it's not caused by gravity, or what it is. It can be contested. There are ways to anyway.
I mean, yeah. I mean, it's kind of suspicious. Like, if you ask me, like, refraction of light in plasma can actually mimic the same thing. But allegedly, it has been removed by, when the people studied, this famous Eddington experiment, in air quotes, when they proven, in air quotes, general relativity by light bending near the sun. It's not guaranteed that it's gravitational 100%.
Anyway, now you can see my screen, right? See, right?
Yes.
Right there. There's the core of the galaxy, and there's the lensing. Oh, it's almost off frame, but there it is. Anyway, let me turn screen share back off, because it doesn't look as good. Hold on a minute. All right. So, anything about the Electric Universe before we move, or the Electric Universe or plasma cosmology, before we move on to the end is near cults?
Well, I just gotta say that I really recommend you to watch this video by Bob Johnson, because he's actually one of the most diligent researchers that I know in this realm. Let's put it this way.
Yeah, I mean, I think most cosmologists most people who don't have their head completely in their you-know-what are aware that there are electricity and magnetism-driven processes going on in certain portions of space. I think the beef that everybody has is that the Electric Universe and plasma cosmology people are suggesting that overall motions of things like planets, stars, and galaxies are governed by a bunch of gas or electricity or something. It doesn't make the slightest bit of sense. So that's, and and you've brought up a lot of the main beefs with Electric Universe, because they say things like Einstein was wrong. It's like, then why are there so many spacecraft flying around Jupiter and things, and being very good at calculating the mass of Ganymede?
Yeah, I actually have a video specifically on electromagnetism in space where I describe some of these things.
Oh, yeah. I remember it. So, yeah, once again, folks, make sure you go subscribe to Eugene's channel. It's a delight, and we need to get him over 1,000 subscribers so he can be monetized. Then YouTube will do stuff like recommend his content, theoretically speaking.
I don't know how it works. But
so since Eugene is a member of the Vladimir Putin cult, let's move on to the end is near cults. Do you think that is Putin going to begin a war that we can't stop with against the Galactic Federation?
Possibly, yeah. Why not?
Do you think?
I mean, all the right-wing people love Putin, don't they?
I think so. Do you think that?
Which is kind of hilarious.
All the left and right wing people are all authoritarian warmongers who want to fight Putin. Last I checked, I think, but I don't know. I don't pay attention because I don't care what any of these partisan hacks have to say about anything, so I don't listen.
It's the big boys. The big boys are playing. It's not for us.
Yeah,
regular people.
I'm interested in actual important stuff, not how much polonium-210 is in the beverages. Well, that's what happens when you're not a fascist who attempts to censor people.
Okay. Maybe you just got demonetized for saying
Anyway, end is near cults. There are plenty of those on YouTube. Shall we
Mhm.
shall we bring up some end is near cults? Now, of course, there have been many end is near cults, and some of those cults really tried to bring about the end of modern civilization as we know it. The best indicator, or the best, I'd say probably the most damaging cults would be the cult of Stalin, the cult of Mao, and the cult of Hitler over the 20th century. I mean, those were the worst cults. They certainly all believed nonsense. They certainly were massively invested. They had a single living leader.
Yeah, but that's kind of the opposite of end is near, because they actually were trying, well, supposedly, to build a better future.
That's true. They were trying to create a utopia.
Yes, yes.
You're right. So, you're right. Good point. That's a distinction between the most deadly cults over the past 100 years. I think it's safe to say those are the most deadly cults over the past 100 years. But there are plenty of end is near cults that are pretty deadly, that are probably still around to this day. Who knows? Somebody may be cashing in massively expensive real estate holdings in order to move to Colorado, where the bunkers are at the perfect depth.
Yeah, and we're the Denver airport conspiracy.
Yeah, I guess. I mean, there are large expanses of bedrock there, so why not occupy the same bedrock as the Denver airport, more or less? What could possibly go wrong?
Well, I've said this many times, and I think the end is near cults are much more prevalent in United States than anywhere else.
All right. Yeah, I mean, I suspect they are, and it's probably because the relatively short-lived nature of the communities that are currently occupying North America. They're very young. So, I mean, as a constitutional republic, the U.S. is very old because the U.S. Constitution is really old as far as like a government that's been in place intact all that, well, more or less intact all that time.
Technically, like France is like the big first republic, but the United States was established before France became a republic. So,
okay,
even though it was based on French ideas, essentially the French Enlightenment, and again, Ben Franklin was a French spy, obviously.
So anyway, one of the most famous. Although a lot of cults eventually they evolve into into the end is here cult, right? This is how they convince their people to do things that are
to drink the Kool-Aid, right?
Right. It's how they convince people to do things that are even worse than their regular daily activities, which are already ridiculous. So if you convince people that the galaxy is going to kill you, then it's kind of creepy, especially when you start building schools. What say you?
I mean, like what I don't like about this is that it's an over focusing on stuff beyond your control. This is kind of bad about it.
Yeah,
this is unhealthy.
I think
you just worry, and like there's no out of it. You can't do anything about it. So like. It's just adding anxiety where it's not really needed. You have enough anxiety without.
I hear you. Like if you're overly worried about cosmic ray flux, you like start investing in some lead clothing or something. At least do something that's somewhat sensible about it. Get some duranium and encase that inside a lead shielding, and encase that inside a Kevlar, and encase that inside a nylon.
You need a Faraday cage as well.
Well, yeah, of course, man. I mean, what do you think? You think I'm a savage? Of course, I have some plastic tubs that uses Faraday cages. By the way, there's been people on the internet saying that certain channels that talk about space weather on a daily basis seem to think that polyethylene tubs are basically Faraday cages.
Yeah, that's weird. I haven't heard about this.
Yeah, you could say weird, you could say hilarious. Or what about this one? From the exact same cult that I will leave unnamed. How about this one? We thought after the event that cannibalism would be a good idea because there'd be a lot of protein around. However, now that so many people have taken a certain type of experimental medical intervention in the form of an injection, now we don't want to eat those people anymore. Cannibalism is bad because
it's
of
GMO.
these pharmaceutical.
GMO.
Correct. These pharmaceutical interventions have talked us out of cannibalism, man. That is
kind of
how
neat.
that is how out of gas. Some people are so out of gas that their crazy cosmology theories required a grand solar minimum.
Mm-hmm.
And that requires 2 consecutive week solar cycles in a row. And I've got Twitch running right over here. And my full screen monitor is on that feed, and guess what? There's a bunch of active regions on the sun and another crown prominence erupting right now.
Did you see the link that I've sent to you from the European Space Weather Service?
I didn't. Hang on a minute. And we're back. I just paused there because Eugene was sending me a link, and I'm not going to display it, but we'll put it in the description once again.
Yeah.
Okay, now cults in general. No need to really cover that. Let's talk about scientism for a brief moment. In 2020, you may have noticed that in the U.S. in the year 2016, when Trump became president, a lot of people became very angry, but they didn't get smarter, but they became magical political analysts. A lot of people became experts in politics who still clearly knew nothing about politics, but they would be happy to tell you all about it on social media. The same thing happened in 2020. Everybody became a virologist. I mean, I know people that are over 60 that just learned how to wash their hands in the year 2020. So what do you have to say about scientism, Eugene? Scientism.
Yeah, well, I have a recent video about how science is not a worldview, and I still stick to it, basically. I'm a philosopher. I'm not really a scientist, first and foremost, even though I'm kind of trained in science, but I know its limitations. I'm not absolutizing science in this sense. Because again, science cannot be a worldview because it doesn't have any inherent value system in it, ethical system, etc.
Right.
Like what's good and what is bad. Science is about if you do X, then Y happens.
It's about what is,
this
not
is
what's
pretty
good
much
or bad.
That's pretty much it, but it doesn't tell you whether X or Y or Z is good or bad. You can do with it whatever you want, pretty much. So it's a tool, like a hammer or a knife, and you can use it, to whatever end goals you have, whether they're good or bad in itself, basically. So yeah,
I tend to agree with that.
So science cannot, and you can see it again in 20th century, as you said, Stalin, Hitler, Mao. They've been using science for, arguably not the best end goals. So,
well, I mean, a lot of people destroyed their own inventions long ago because they realized that the most applicable use of their invention was as weapons. And of course, you could make a weapon out of practically anything. I mean, this is one of my pals who now has a PhD. Actually, we used to make fun of him because he would make weapons out of everything.
nice.
And gee, don't worry, no worries, folks. He's just a biomedical engineer now. What could possibly go wrong? Seems like a perfectly great choice. Now, of course, that's not really what he's doing, okay? What he's trying to actually do, which he's been trying to do for over a decade now, is invent the thing that Elon Musk wants, the neural link. He's been trying to figure out a way to make a neural integration to electronic components that actually works well. And he was doing this long before anybody knew who Elon Musk was. In fact, I even helped him out a little bit with it. I used to have one of his patents used to actually be in my lockbox before my house got burglarized. So somebody got some crazy document and my passport and the ball cock from my boat was stolen.
You seem to be living in a very friendly area.
Oh, it's well, I'm not there anymore. I'm not there anymore.
Okay.
I've that place. I was just on the bike over there, uh, just yesterday actually, and I ain't going back, dude. I ain't going back. I'll be there at a very very rare occasion.
Hmm.
It's I look at where I am now, and I look at that, and I go, ew. At
How,
that, not the current. You get the idea.
how's it overall feeling right now? I mean, you're not super young, right? You remember like the 90s, maybe early 2000s.
Yeah,
Like,
I mean,
is it getting better in Pennsylvania?
I
Or is it?
graduated in 1994 from high school, so
Yeah.
yeah, so the 90s. I consider myself like a 90s kid, basically.
Hmm.
Well, it's coming back. I mean, literally right now, you can expect to see all the crap from the 90s. So people are going to start wearing flannel shirts, doing heroin, the whole deal. Pale skin, grunge music is going to come back. Watch, I guarantee it. It's
Well, I mean,
cyclical. Fashion, all of these sorts of things.
I mean
Fashion music.
the Springsteen song, the Philadelphia or the Streets of
Oh,
Philadelphia, which is like a complete dystopia, right? So is it better now? That's what I'm asking. Or is it getting worse?
Springsteen's from New Jersey. First of all, so like if he made a song about Philly, it's BS because he's not from Philly. He's from Jersey.
Hmm.
So let me just discount that immediately. I don't even know what song you mean, honestly, because I can't stand Bruce Springsteen.
It's called
And
Streets of Philadelphia, literally. It's probably his
Bruce
most famous song.
Bruce Springsteen is like a sweatier, less skilled version of Tom Jones. Okay, imagine like Tom Jones. You know Tom Jones,
No, I don't. Is it the Black Betty guy?
the guy from Wales. The sweaty womanizer from Wales. She's
Yeah,
a
it's the
lady. Whoa, whoa,
Sex
whoa,
Bomb
whoa,
and
she's a
yeah.
lady. Talking about she's a lady. That guy, Tom Jones.
Wait, he's
I saw that guy play live, dude. He was sweaty. I get it was very very hot, and we did nitrous oxide from a dentist's office right before going to the show, and that's just one of those
okay.
connections,
I
dude.
feel like our conversation is quickly
We have devolved
diver-
into utter nonsense. All right, so let's move on. That's what happens when you talk about scientism, man. We just went from science is your religion to Tom Jones is sweaty.
Yeah, so
I like Tom Jones though. Nothing against Tom Jones. That guy's legit.
to summarize my point, it's like science cannot replace religion or like
Right.
aesthetics or philosophy because it lacks the ethical component
I meant to say
inherently.
that. Right. It takes up a different file in your brain. Like it's not the same thing. It's
Science is how do you do stuff most efficiently rather than what kind of stuff do you need to do, you know?
yeah. Like it's what is the stuff? How does the stuff work?
Yeah,
Ethics is should I do the stuff?
exactly. And that's kind of the tragedy of the 20th century and arguably the beginning of 21st is that, we don't have that anymore. Like previously was controlled by religion. Like you've had some ethical system at least. Of course, people were still corrupt, and the elites were corrupt, etc., etc. But at least that there was some beacons
Yeah.
out
And
there
by the
in
way,
ethical.
ride bikes, but it's not your religion, dude. Cycling is not your religion, and neither is science.
Hmm.
Anyway, so all right, so let's talk about your earthquake forecasting. I know you brought that up. We should maybe make a video entirely about this where we actually pour through some of the
Yeah,
data that you looked at. But let's talk about
yeah.
earthquake forecasting because there are a lot of idiots once again on YouTube that claim they forecast earthquakes, and that includes both. There's two channels that are very very big that have over 500,000 subscribers on YouTube that will both remain unnamed. That have I haven't heard it for a while, but their viewers tend to claim that these dudes are forecasting earthquakes. Eugene, can we forecast earthquakes from space weather?
Uh, I mean, the exact answer to this question is I don't know, because what I can tell you is that I've tried so many different things, like various methods, and yeah, we probably should talk about it in more detail sometime. But I've looked into a lot of stuff, like planetary alignments. They don't seem to work. Well, what else did I look into? Like the barycenter of the Sun-Moon system doesn't seem to work.
Okay.
The plasma connection through the solar wind of different planets. That's what I call the plasma astrology. It doesn't seem to work. What else?
So this is part of the when Earth moves past Jupiter, it gets magnetically complex. It gets magnetically connected to Jupiter.
But it does. It does.
No, I know, but it's an incredibly weak thing through a bunch of gaseous
it's
plasma.
not very weak. It's not very weak. We can even catch cosmic rays from Jupiter through that.
All
through
right.
these.
How do you know that?
Basically, well, it has been documented. It's not my idea.
There's some kind of a directional aspect to cosmic ray flux at times of Jupiter being around Earth.
No, it's not. Look, like when imagine we have the solar wind, right? And it has this Parker spiral to its flow, right?
Mm-hmm.
Know what a Parker spiral is? It's
Parker
this,
spiral.
as the sun
The
rotates.
heliospheric current sheet, yes.
Well, not necessarily. It's related, of course, but it's a slightly different thing. But the Parker spiral, like as the sun rotates, it's like a sprinkler, right? It throws the solar wind outwards, but it also rotates, which means that these outward flows of the solar wind are curved, right, into Archimedean spiral.
Mm-hmm.
So that's what a Parker spiral is, or is it the logarithmic spiral? I'm actually not sure.
I have no idea the difference between those two things. So I've taken geometry. I don't know.
I don't remember. Sorry, I think it's Archimedean, but never mind.
Who the hell cares? You goddamn detail-oriented maniac.
So there is this spiral, which means that when we're sitting on the same spiral line with Jupiter, for example, we are connected to it with the magnetic field lines from the sun that are basically embedded into the solar wind.
Sure.
Of course, people are freaking out about this idea of a frozen in air quotes magnetic field lines, but I mean it's a good approximation.
The plasma aligns to the lines, and it works like a line, basically, because it's a continuous.
Yeah, that's the Lorentz force causes both protons and electrons to spiral around the magnetic field lines, which is essentially like the main thing in plasma. That's what causes the coronal loops, for example, and everything else like that.
That brings up a super important point. We should make a new channel called Ian the Ion.
Okay, it's your stupid idea.
It's about a single hydrogen nucleus that's flying around in space, doing various things. Interacting with this, interacting with that.
I'm sending you the paper about cosmic rays from Jupiter, by the way.
Better yet, even just flying through a plain old void. Maybe we should start out with that. Just, hey, look, it's Ian the Eon. It's Ian the Ion. It's flying for eons through an empty void of space with nothing around.
The eons are closing, though.
The eons are closing. That's true. Which brings me to the next point. We're at 38 minutes here. Actually pushing 39. So yes, you brought up a lot of the things we talked about there, like earthquake forecasting, the planets, the barycenter. Do you think planetary alignments control the sun's activity?
No. Right. I've looked into it. Actually, I've spent a lot of time studying this, and I can tell you for sure, at least in the trivials, when there's a line between the sun, Jupiter, and Saturn, you would expect higher activity. Well, no, it doesn't happen like this. I've looked into it for a long time. That's why
you look at a whole rotation when Jupiter and Saturn are aligned. You look at a whole Carrington rotation when it's closest to alignment. You'd expect something to happen.
Yes, it does.
What do you see? Nothing. I know. I looked into it a little bit myself, and I was like, first of all, I don't think it's valid physics in the first place, but I'll follow up on some of these papers that people are sending me, and it's like, dude, stop misrepresenting what the paper says. At least read the abstract before you send it to me.
Yes, and there's also an issue of like solar system barycenter. You know, there's this statement is that, well, when they're like all the giant planets are aligned in some way, like the solar system barycenter is, because you know it's usually not within the sun even. Like the Jupiter and Saturn have enough mass to displace like the center of mass of the whole solar system away from the sun, sometimes even significantly away, like 3 or 4 solar radii. You know,
I've seen the
so
diagrams.
yeah, I can actually send it to you. Like I've looked into it very carefully.
But
And
the
again,
forces are very gentle too. You know, these are not really like violent forces happening.
I mean, it's gravitation. That's the only force we're talking about here.
Exactly. Exactly, which is an important point. But anyway, let's not spend too much time on this as the video's getting
Yeah. Just my point is, like, I haven't seen any correlation with solar activity in barycenter
I have to
position.
pause for a quick moment, just a minute here. All right, we're back. And what are we talking about now? Planets.
We're talking about the barycenter.
Okay,
yeah.
so let's move on from that into the realm of cosmology nonsense. And that can include any cosmology nonsense, whether it's the idea that electricity governs the orbit of the Earth, or that, you know, that, I don't know, I'm trying to think of something that's more commonly accepted in the realm of cosmology. Oh, I got an idea, that there are quark stars. How about the idea that there are quark stars? That sounds like cosmology nonsense to me. It's somebody goes, hey, we saw a crazy thing happen. Let's come up with an insane theory to explain it, backed up by nothing except one observation, shall we? That's cosmology nonsense.
Yeah, so in case you don't know, I've actually spent my whole academic career, if you can call it that, was devoted to studying quarks. And like, with all sincerity, I can tell you that the theory of quarks is BS. Like, even though, like, technically I've spent, you know, like
But why
7 to 8 years.
Eugene, we can take a proton and break it into another thing, and then break that thing into another thing, and break that thing into another thing for the rest of our lives.
Well, on paper, yes. Like theoretically, maybe, but no, it's not the case actually.
That's good.
Like,
Seems
like
to make functional physics more important than, I mean, you know, not to discount theoretical particle physicists, because that is, after all, your area of expertise. And of course, usually, you know, I think the beauty of being a theoretical
that's exactly what I'm saying. That basically, like, it's a crap theory, not crap, by the way. It's just a crap theory that, and I've kind of wasted all these years working on it.
Well,
It's just wrong. I mean, I didn't waste it in the sense that at least I know it's a crap theory, right? So in this sense,
it's the worst case scenario is that you figure
it's
out.
like the Edison, you know, he says that I found out like 1,000 ways that do not work, you know.
Right. Yeah. The what was it? That must have been the origin of the carbon light bulb filament, right?
Yeah, something like this.
Oh, jeez.
Or tungsten,
Nice.
like whatever they used.
Yeah. Well, I mean, now they're tungsten. I don't know. I don't know exactly what happened there. He stole somebody's idea and had that guy rubbed out and encased in concrete or something. The guy that came up with it. He came to him with a tungsten idea, and he's like, "Did you patent that?" And the guy said no, and then he mysteriously vanished.
No.
All right. Anyway.
Who could have thought?
So yeah, so cosmology nonsense. I mean, oh, and fun fact, I don't know if you knew this. Did you know that when I was in college, I actually considered majoring in cosmology, but there was only like one college in the whole U.S. that had it as a major. So which didn't really discourage me, but it would have just been a matter of doing, like, I don't know, astronomy major with a physics minor, or vice versa, or something like that.
Mm-hmm.
But I was like, there were some issues. I mean, I was really disappointed, man. When I took college astronomy, I was like, oh, this is going to be crazy. There's going to be like a whole chapter about the sun, all these inner working stuff. It's really, really important. How this is like, how this dictates what's going on with all the rest of cosmology. And I was like, what? There's like 2 sentences on the final exam in college astronomy 1 about this. Well, in the mid 90s there was. Who knows what's going on now, but it was extremely badly understood. And of course, back then we used to call quote supermassive black holes massive radio sources, because it's like, here's a thing we see other things orbiting at the core of a galaxy, and it's emitting radio frequency. So how about if we call it a massive radio source, since we can confirm these things about it?
Yeah.
And of course, that is where you can see science idiots getting into the weeds on YouTube. When you see somebody on a science channel that gets into the weeds, they don't know that they've gotten into the weeds. They start saying things that make 0 sense from a physics perspective. And then you go, ew, that guy is a complete cretin. You ever seen that happen? You know, you're like watching a channel about space weather, and then you realize that they don't know that a CME and a solar flare are different phenomenon. And you're like, what? He's showing the Enlil spiral, and he's talking about a solar flare, which isn't visible on an Enlil spiral. And you go, dude, you're looking at plasma, but you're talking about photons. You are an idiot. You should get back in your lane.
Solar flares do send shock waves through the plasma, though. Like, it's a known phenomenon, and it leads to like cosmic ray flux enhancements sometimes.
I would imagine it would. It is a path of least resistance for the plasma in some ways.
Shock waves. When people say shock waves in plasma, it basically means electric currents, like current sheets, actually. So yeah, there's that.
I imagine it can both accelerate or decelerate photons, because you've got a magnetic field.
Not photons, the cosmic rays. You cannot decelerate a photon, at least according to special relativity. It always moves at c.
Well, right, but if it's going to take a longer path, then it'll take a longer time to get to the target.
I mean, the solar wind plasma is so diffuse, it basically doesn't impact photons in any way. Again, if we're discounting effects like refraction of light around the sun, like, you know, when we're talking about the gravitational, thick air quotes, lensing by the sun.
Anyway, these sorts of topics are the reason why we have to make a channel called Ian the Ion. It'll be good. We'll make little cheesy animations that are custom. We'll get the channel monetized. We'll send you half of the cash. It'll be brilliant. And you'll be able to plug Eugene the Philosopher, which is what I'm going to do right now. Everybody, make sure you go subscribe to Eugene's channel. Check it out. He's got 412 subs, and he knows more about most of these subjects than your favorite noobs on heavily overpaid news channels. All right, anyway. So back to our list of talking points here. Let's see. We've covered planets, barycenter fails, cosmology, and nonsense. Let's get back to heliophysics and solar flare anisotropy. What is any sort of a valid, what would you say is any sort of a valid hypothesis as to why we would see more X-class flares around the limbs of the sun than in the center of the solar disk? Why would that be a thing, Eugene? Is there any valid physics explanation for this?
Well, my initial hypothesis that I kind of still stick to is that there is an anisotropy of the flares themselves. So the same flare would, in air quotes, appear brighter when it's at the limb, because the flare mechanism itself is anisotropic. Like there is a different brightness to the flare depending on the angle you're observing
Could
it
it be
at.
that
So,
maybe gravity is just flattening out the magnetic loops? Because now you're looking at it more perpendicular, so material is
yeah.
less
So
likely to make a really hard turn because of the magnetic loop being sort of flat from your perspective when it's like directly
yeah,
facing you.
yeah. And I've read some hypotheses. Like people actually do not doubt this for hard X-rays and gammas. It's actually kind of somewhat recognized because of the difference in like electron distributions in terms of like where are they going. So there is more Bremsstrahlung, so-called, which means like
The breaking
breaking,
radiation.
breaking radiation from electrons at the limb. But then again, it's supposed to be like hard X-rays and gammas. It's not supposed to be happening for soft X-rays, which is what we observe the flares at 1 to 8 angstroms. It's soft X-rays. It's like 1 keV to maybe 10 keV energy, whereas the hard X-rays are like hundreds of keV basically. So for them, it's recognized that Bremsstrahlung is different under different angles, and that's what drives this anisotropy. But for the flares themselves, the soft X-rays, it's not considered to be happening. Yet I think that what I've detected is actually, it confirms that it is actually happening. Like whether it's Bremsstrahlung, like some lower end of it, or something else, I don't know. Like I didn't, study the flare mechanisms, etc., because it's all
I think
described in terms of magnetic reconnection and all the crap like that. I didn't want it to even like start working on it, but
I think there's a sweet spot where the flare where the like it, for example, in X, let's just say X class flares only.
yes.
I think there's a sweet spot for the X class flare to occur, right? Because
Sweet
and
spot in what sense? What do you mean?
you know how close to the limit is, and including
Okay.
whether it's behind the limb or not. Because again, like you said in your video that you uploaded today to YouTube about the paper,
Mm-hmm.
like you said in that video, the flare is occurring up in the corona.
Yes, yes, yes.
And the the sunspot is like a depression in the photosphere, and there's even a
Uh-huh.
layer in between there. So, in a lot of ways, the most exciting prospect about studying any of this stuff is figuring out what's happening in the chromosphere.
Yeah, could be.
Because I mean,
But
it's like
Mhm.
with these we only see large flares. It's you almost never see a large flare where there isn't an active region.
I don't think you ever see a large flare without an active region. you,
Yeah,
you can
maybe
see
not.
CMEs. I mean, on the so-called Hyder flares, right?
That's what they're called. I
HYDER.
was looking for
Yeah.
that this morning and I could not remember or find. That's when the plasma splashes back down toward the chromosphere,
Yes.
right?
So when the filament erupts, there is a brightening of the photosphere. Like this. Just like today in your video, by the way, when this filament erupted in the north, you could see like this expanding sort of hot canyon of plasma on the photosphere, right? This is what drives Hyder flares. Like this is the mechanism. Like when this cold filament erupts, there is a brightening of the surface, and it's very long usually. Like you can see it in the ghost graphs, the Hyder flares are super long, and they're usually much weaker. So
Absolutely.
yeah,
Yeah, I mean,
but you don't get X-class Hyder flares. I don't think it's even possible.
yeah,
They're usually
it's only
like
like B and C class, I think.
no. It could be M, like maybe M5, but not more than that.
Yeah, this one actually wasn't particularly it wasn't particularly beefy. There was just like sort of a bit of an increased
Yeah,
X-ray output there for an extended period, but
I don't see anything on ghost graphs. Yeah.
it wasn't like super beefy. Yeah, I don't even think it showed up. It wasn't beefy. It was kind of.
Mm-hmm.
But sometimes you'll see an event that'll come up. You'll see like a little secondary C flare or something. I don't
Mm-hmm.
remember seeing an M or anything like that.
I should have something in my in my archive. Let me look into it. Send you some hider flares. Okay, yeah, it was C class on October 20th, 2015, for example. There was a hider flare, and it was like C5 roughly.
Is that too early for the SDO?
No, you could see it on SDO. I just wait.
What was the date? 2015?
Yeah, 2015, October 20th. Oh, 22nd, sorry. October 22nd. Yeah, it's C, basically, C class.
Should be good.
Then another one is on April 5th of the same year.
Let me give that a minute to initialize. I'm going to press pause. All right, anyway, folks, here's one of the examples Eugene was talking about right here. You can see some plasma splashdown, which does lead to some secondary flaring. Anyway, enough of that. Let's move on. And the next is just heliophysics, right? Can you explain? Can you explain how heliophysics is cosmology?
Well, quite literally, the only stuff we see because the universe is illuminated by stars. And therefore, if you understand stars, you understand most of the stuff we see.
And how is it that we understand what's happening inside of Betelgeuse or happening inside of Altair?
Yeah, I mean, it's a long shot to claim we do understand what's happening there, because
But I mean,
think we don't.
But the basis for those claims is that we understand what's happening inside the sun. No?
Exactly. Yes.
Okay.
Yeah.
I just wanted to tie that together.
Yeah, and one of the last, well, not the last, some of the recent works of Robitaille actually has shown that the so-called Hertzsprung-Russell diagram, the stellar, classification,
the stellar evolution,
spectral classes, it's kind of BS because it doesn't
color, the diameter, and
yes.
And what he's basically means, what he's talking about here, folks, for those of you who are not familiar with the Hertzsprung-Russell diagram, it's a reference to the idea that viewing the color and diameter and brightness of a star, you can figure out at what point that star is in its life cycle. You could, in other words, looking at those three things, I believe it's just those three things, isn't it? It's just the...
Yeah, but the thing is, there is a so-called main sequence, right, where the stars, most of the stars, lie, but there's also separate areas which do not fit into the main sequence.
And for example, Wolf-Rayet stars, they don't really fit into the continuum.
And it's kind of if you look into it in more detail, you start to understand that it's kind of
it's all over the
unfounded. Place, it's kind of unfounded, yeah.
Right? And to make it as weird as it could possibly be, right? A star that we talk about regularly on the channel is actually, I believe it's on the screen right there, the brightest star you can see over there. Anyway,
it's the G2, I think, class, right? Technically, yellow dwarf. Or which star? I was talking about the sun.
No, I was talking about Deneb, but because this star background that we have is Cygnus, and it's for a reason. It's because Deneb is the only known cosmic ray point source that I'm aware of, and so that's why we have that up there. It's also the brightest star in the constellation Cygnus, and even Deneb doesn't fall into the proper category because the bright star is a blue supergiant star. Okay.
And just FYI, we're actually the closest bright star to where we are going in the galaxy is Deneb. This is roughly where the sun is heading as we rotate around the center of the galaxy.
Correct. Yes, it's sort of the vector that the sun and the entire local group actually takes.
Yes. Everything around us moves there, pretty much. Yes.
Right.
with a velocity of around 255 kilometers per second, which is a lot.
Yeah, I mean, it's like solar wind level
Yeah,
speeds.
yeah.
The solar wind was recently down all the way to 275, actually.
Yeah.
So,
Well, typical solar wind velocities are around like 400, and that's a slow solar wind. Fast can go up to 700, obviously.
right. So, but the point is, it's a significant percentage of the speed that tiny little bits of diffuse gas are flying through the solar system. We're talking about entire groups of stars here. So,
Yeah.
they orbit the galactic core at very high speeds. And I have no idea where the hell I was going with this. Because Deneb doesn't even fall into the normal Wolf-Rayet star. Normally, a Wolf-Rayet star is a blue supergiant that has a white dwarf companion. This one doesn't have a white dwarf companion at all. And if you want to read all about it, hit up smashomash.com/forum. There's a whole forum thread just specifically about this one star because we thought it was kind of important to do some research into it. And this is one of those ones that the deeper you go, the weirder and creepier it seems. I mean, those of us who understand how cosmic ray flux actually works, we're well aware that this thing's been sending physical particles through our brains for our entire lifetimes. What do you think about that, Eugene? Is that don't you think that's a little bit on the creepy side?
No, I don't.
I kind of like it.
Well, regarding, like, again, you might
It's
disagree
pretty far
with
away.
me.
I mean, it's in the Cygnus arm. It's not like in this
Yeah.
part of the galaxy at all. It's like a third of the way across the galaxy.
No, Deneb is really close.
There's a huge disparity in people's understanding of this.
By the way, like the way we measure distances is also screwed up. Like it's completely wrong.
Not when it
Essentially.
comes to parallax, only with redshift
Yes.
measurements.
Yeah, but the problem is that the parallax is also subject to all this like plasma refraction and things like that. So I don't know. I mean,
It
it's
is
sus.
a little bit. Yeah, it's got to be. I mean, okay. I can see this
Wait,
point.
parallax. Okay, Deneb is actually 2,600 light years.
It's in the Cygnus arm, man. Yeah,
That's a lot. That's a lot.
Yeah, but some people think it's like 12,000 light years away. The estimates are all over the place with that one.
Yeah, plus minus 200.
Yeah, the margin of error is 300% on some measurements. So
no, it's not 300, but it's a lot.
On some measurements, it's 300%, where they're saying the distance is between 8,000 and 24,000 light years. Mm-hmm. That's a that's a big margin of error, man.
Well, exactly. Like if it's in a different galactic arm, there should be a lot of stuff in it, so it probably refracts the light quite a lot.
Well,
so.
yeah, and the thing to understand is that if it's sending particles here regularly all the time for decades, you're part of its stellar sphere. So in this strange respect, you are connected to it in a very real and it's sending particles through your brain sort of way. And I'm not kidding or exaggerating here. It sounds crazy like science fiction, but trust me, computer scientists will agree that it is all too real.
Mm-hmm. Yeah.
Eugene doesn't find it creepy, though. I mean, I find it kind of creepy because what if the amount of flux coming from Deneb suddenly and drastically changes? Don't you think
I don't think there would be any difference to us, to be honest. I mean, there would be some, right? But not very important.
Yeah, there would be some.
That's what science is actually good at recognizing how important something is, because if you can quantify the effect, you can tell like whether it's important.
Anyway, a little bit more about Deneb. Deneb is part of the reason why people say words like quark star, because the object that is orbiting the Wolf-Rayet star is orbiting at such a high speed, and the output from the star is so high, it's something like 10 times the stellar wind density and stellar wind velocity of the sun's output. So it's about, I think it's like 160 times the diameter of the sun, which means if it were in our solar system center where the sun is, you'd be inside of it. So would Mars.
Wiki says 200.
200
Yeah.
solar diameters.
Yes, yes.
Yeah,
But it's plus minus 17, so.
you see what I mean? But it's very variable, and it's an X-ray source.
But then again,
X3
it's all based on this, standard in air quotes theory of
well, no,
stellar evolution,
I
which is.
understand that, but the diameter is sort of the diameter when you're taking a measurement of a thing.
But you can't measure the diameter visually, no? Like it's too small.
Oh,
Again, like
I don't know.
it depends
I
on
don't
how
know
far it is, right? Because
for sure.
the
But
same object would appear twice as larger if
it's
it's twice
I'm not
closer
even
to
done
you.
explaining what it is yet, because it's also an X-ray binary. So it has this little friend, as it's called, which is known as Cygnus X3, and that's the separate and compact X-ray source. If you read, have you read the thread on the forum, Eugene? Because
No.
there are some. I mean,
Well, as
I'm
I've
sure I
said,
didn't
like
pull every.
in the last 2 months, I've been grinding my paper, bro.
Well, these papers have been posted on there for years,
Mhm.
but it's yeah, it's a known thing. All right, this is not. I'm not talking about any crazy conspiracy theories here. It's just it's part of the reason why the word quark star is a thing, and the orbital periodicity of this object is 4.8 hours.
Mm-hmm.
So
Well, it's quite fast.
yeah, it's doing an orbit that's like the size of Jupiter's orbit in 4.8 hours. I don't know what the hell that means, but that's one to maybe look a little deeper into there.
Isn't it like faster than light already? If that's the case.
Yeah, I don't know. It seems like it would be awfully fast. I don't know how that would be a thing.
Okay,
If
I don't want to make the calculations. Or
if the star's diameter is like somewhere like around the size of Mars's orbit, even, how does it do a 4.8 hour?
200 solar radii. So one solar radius is, I think, 0.025 astronomical units. So if you multiply it by 200, that's actually the order of astronomical unit probably. As 0.05, and you multiply it by 100. 5 astronomical units. That's Jupiter orbit.
So it's like almost exactly light speed.
I mean, the size of Deneb itself is the Jupiter's orbit radius.
Jupiter's orbit, right?
Yes. Well, slightly lower than, but
But this, I mean,
close.
if you, I'm seriously read the papers about it. There's a compact object that orbits the Wolf-Rayet star. It has its own disk of plasma, which is the X-ray emission source. So like Lagrangian point 1 of the star versus Lagrangian point 1 of the little friend is where this disk of ionized gas rotates to the point where it is the X-ray source.
There's only one Lagrangian point 1 for the system of two bodies. There can't be two. Like there's only one. Like that's the definition of Lagrangian points, is that you take a pair of bodies, and there's like L1, L2, L3, L4, L5.
No, you're right. You're right. It may be that the disk of plasma has its own, but there's like a permanent feature there in between the one gravitational source and the Wolf-Rayet star. And there is a distinct plasma feature that acts like an eclipsing binary.
Well, let me just...
So at one point of its orbit, the one polar field is oriented toward you, the observer, here on Earth. And at the rest of the orbit, it's behind the Wolf-Rayet star. So it's like an eclipsing high-mass X-ray binary Wolf-Rayet star with an even more massive object orbiting it for some reason at relativistic speeds.
Let me just summarize this with my own statement, which you can also disagree with, and I think you will. But anyways, I've told this to you like many times before, many years ago, that's why I don't like anything beyond the solar system because it's so far away and it's so prone to hypotheses that it's like we can't even measure the size of the thing, the distance to the thing, so we can't really make any conclusions about what it's up to, what it's doing.
That's true.
That's why I like very dry studies.
But you can
just
make
like
some
the one I did
assumptions about it,
just
because it's a cosmic ray source and it's an X-ray
of
source.
course. But it's still in the realm of fantasy, essentially. It's the Tolkien or Harry Potter, essentially. Like we can make like whatever statements we want because none of them are falsifiable anyway. We can never go there unless we discover FTL or whatever. So yeah. But with regards to the sun, though, or the planets, or the comets, the asteroids, we can go there. Actually, we can make all kinds of measurements. So that's why I prefer, intra-heliosphere type of studies.
Oh, I got you. Yeah, I understand for sure. I mean, you run into the problem very quickly where if you're looking into a spotlight, you might really have trouble figuring out information about the source. So that is definitely a problem constantly in cosmology because it's a known thing that a galaxy looks completely different based on your perspective. Are you oriented perpendicular to its pole, looking right down its polar field, or are you looking across its disk where it looks like a radio galaxy? It's looking more and more like galaxies are more and more similar as time goes on, it seems, and a lot of the differences are just based on perspective if you're viewing it edge on versus viewing it down the pole.
Yeah, sure.
Anyway, so
should we go to the other topics?
Yes, we should certainly go to the other topics. How about anything interesting lately in plausible cosmology besides?
Well, as I've said, I'm skeptical about cosmology in the first. I mean, there have been this news story about how James Webb consistently discovers older and older galaxies and it kind of breaks the Big Bang theory.
Hey, this one's 20 billion years old and it looks just like the ones that are right next to us. Yeah.
And there's all kinds of old stars somehow. I mean, according to this Hertzsprung-Russell diagram anyway. So
this star's older than the entire universe. Don't that's not an affront to cosmology itself or anything.
Yeah. So I have a video again called Logical Cosmology, where I basically make a statement that the universe, if you define the terms, seems to be infinite in time and space. So I don't believe in Big Bang. Basically it breaks the causality, which essentially is unscientific in the first place, right? You can't have science if you don't have causality, because again, science is about if-then statements. Well, if-then statements rely on causality. So if you don't have causality, it's not science anymore.
You better at least test it. Yeah.
I'm not saying that science is, be all and end all. I'm saying that if you're doing science, you cannot get rid of causality. So Big Bang is essentially inherently an unscientific theory. So that's just what it is, I'm not saying it's bad for Big Bang. You can believe in it if you want. You can believe in creation, which Big Bang is essentially. I'm not against it. It's your choice. I'm just saying it's not science. That's all there is.
If you can't test a thing, how could it be science?
Yes, also, yes. Science works with repetitive things, again, if then. So you have to check whether it repeats. If the same then follows the same if all the time, it means that it's true, right? But you cannot do this with the universe, because the universe, there's by definition only one universe. That's what is called universe, not multiverse or whatever,
No, a lot of people call it the multiverse because
again, in the same video, I prove that there is no
not
multiverse.
Science, since they can never test on it.
Yes,
Which brings me to an important point about the cosmic microwave background, which I have huge beef with because there's microwaves everywhere you go, especially in space.
Yes.
So let's say you're just outside the Earth-Moon system, right? You've left the Earth's magnetosphere, and you're not way over here by this galaxy in the constellation Cygnus, but you're just kind of right by the Earth, but you're, I don't know, 25 Earth diameters away. You're outside the magnetosphere. Let's say you're 3 times the distance to Lagrange point 1, right? You're 3 million miles away approximately. You're completely outside.
You mean L1 of Earth Moon or Earth Sun system, because they're
Earth
different.
Sun system. Yeah, Earth Sun
Okay.
system. Let's say you're like 3 million miles from Earth, well outside the magnetosphere, right? You're just in empty space, right?
Mm-hmm. Well, I mean, it's not empty. It's filled with a solar flux.
Don't you think all these stars are going to be sending various different microwave frequencies? Don't you think it's
Yeah, sure.
I mean, of course, this constellation is near the galactic plane. It is the constellation Cygnus. So, we're zoomed way in here. This is not like the natural view that you would get if you just looked up in the sky. This is some kind of zoomed in image. I have no idea what the arc seconds are or anything like that. But the point is, there's a lot of microwaves in space. Stars and galaxies, hundreds of millions and indeed billions of light years away, are emitting microwaves, visible light, radio frequency, ultra low radio frequency, gamma rays, petatrons, and all kinds of other radiation all around in space.
Yep.
In extremely unpredictable fashion. There are probably things that we can't see that are that are like emitting. There are certainly things that we can't see that are emitting radiation. Like, in fact, this star background, you see that bright cluster right there? That's the core of galaxy Cygnus A. It's the second brightest radio source in the entire sky, second only to the sun. Guess how far away it is? Estimated 530 million light years.
Just FYI, the universe is actually the brightest in infrared and microwave. So if you're like...
The universe.
Yes. So if you just like tune your detector to radio, yeah, it's somewhat bright. If you go to microwave and infrared, it's incredibly bright. If you go to visible, it's slightly less bright. UV is even less. X-rays is even less. Gamma is even less. So infrared and microwave is like the most densely packed with energy of all the frequency bands. If you just look at the sky, tuned into some frequency, infrared and microwave would be like the largest amount of energy you can receive.
Well, where's it all coming from, Eugene? Where is it all coming from? It's just coming out of
all kinds of stuff.
It's just, it's just the empty space just emits radiation.
No, it's not empty space. It's some stuff,
Oh, it's some stuff.
Yeah, the universe is not empty. Actually, have you noticed that?
Well, there's lots of stuff flying around. There's lots of diffuse gas and things, and there's photons.
And there's I don't even know, quadrillions of stars as well, if you didn't notice. And they emit a lot of microwaves.
They're all emitting stuff. Yeah, I think that's what I was that was the point I was making earlier, right? Not even just stars, but also galaxies.
Galaxies is a bunch of stars, essentially. But also,
galactic cores, those are different.
Interstellar plasma, tenuous plasma.
Yeah, like if you're staring right down the pole of a galactic core and it's super bright in X-ray and you can't see any details about the galaxy because you're looking right down the galactic jet. It's like staring into a spotlight.
Yeah, some people say that, black holes don't emit anything because they consume everything. Well, apparently...
Well, this is an ongoing theme that we see in everything, Eugene. We see galaxies, when their equators are bright, their poles tend to not be bright, and when their poles tend to be bright, their equators tend to be dim.
They're trying to transition to crap theory.
I don't know. I look, I don't make this stuff up, but I watch the sun do it. I mean, the sun, it certainly has bright radio frequency jets at solar minimum, and then it has bright radio jets around the equator at maximum. Those things just stay constrained at the poles around solar minimum for some reason.
Well, hopefully
ideas about this.
the solar orbiter would live long enough until the next minimum, so we can actually observe the poles at the minimum.
Yeah, I know. It's gonna be berserk.
That's quite a long shot. It's still like, what, maybe 7 years until the next minimum?
Well, yeah, it's not going to matter because the paper is going to be published long before that happens, and it's going to pass peer review because it's so brilliant.
You mean my paper?
Oh, yours is fine, but I'm talking about.
I meant that we kind of need an actual observation from solar orbiter of the poles during the minimum.
No, we already have sufficient.
No, we didn't. Like Ulysses, the probe that went
necessary.
over the poles didn't have a camera. Firstly, secondly, it was very far away from the poles in terms of distance. I mean. And the solar orbiter is going to be much closer, even though the inclination is not as high because it's using like Venus and Earth, I think. Gravity assists, while Ulysses used Jupiter.
Doesn't
That's
matter,
why
man.
its orbit.
Doesn't
its
matter.
orbit was so huge.
Doesn't matter.
But previous minimum was what? 2019, right? Which means the next minimum would be 2040 or what? 30, right? So 7 years.
Something
Do you
like
think
that?
it's gonna survive? 7 years?
Well, it might be more like 6 years, okay? Because this solar cycle is looking more similar to solar cycle 23 than anything else.
Maybe.
And some people are even calling now for it to be a stronger cycle than 23. I'm not sure about that, but if it's in between 24 and 23, it's going to be a shorter cycle than 24 because weak solar cycles last longer. It's a proportional relationship between.
Yeah.
So I mean but it's not necessary. We've already got more information than we need, and plus,
I don't think we
somebody
do.
somebody else is going to figure it out though, because the paper has to at least be submitted before somebody else publishes the idea. I mean, I can't believe that nobody's come up with this yet. It's not just a inductive reasoning for me. It's a combination of inductive and deductive reasoning. But you get down to the point where you go, I don't know of any other valid physics force that could explain this, along with the other stuff that I do know how to explain. It's just one of those things. There may be some missing pieces. I mean, it is going to be really cool to be able to see the radio jets if anybody notices that they're there at solar minimum. But they're definitely there at solar minimum, and they're definitely around the equator at solar maximum. So there's that.
Mm-hmm. So regarding that, one thing I want to look into following my paper, since I have a huge database right now, essentially, so what I want to do is to look into where the flares are actually pointing in the sky. If you know what I mean? Like,
from Earth's
is
perspective?
the sun? No, from the sun's perspective. Like,
okay,
is it maybe preferentially shooting at some particular points in the sky? That's a question I don't know the answer to. Like, I still haven't done the research.
That's very interesting. I mean, that's
kind of the beauty of research. It's an adventure. Like, you never know what you're gonna find.
Before I forget to bring this up too, let's bring up one more thing before we close this video out. Let's talk about the idea that the sun has a solid core, and because one of the most interesting things that I've ever heard anybody bring up about solar activity, and I never heard this until you brought it up, and I frankly wasn't surprised. And if you notice, I had a theory as to why it happens within 2 seconds of you telling me about it, that there's some weird location on the sun where it's a permanent location on the sun. As it rotates, it stays in the same place. There's a spot where there's a sunspot more likely to occur than any place else. What's up with
that's what I told you. Yes, it's known as
Tell the viewers.
active. Yeah, it's known as active longitudes. So, and it has been like there's plenty of papers on that. Like I can give you quotes for at least 5.
No, is it a specific spot or just a specific lot? So yeah, the exact same spot.
So look, Yeah. So imagine the sun, like if you fix a certain position at it, right, and it rotates with the sun, okay? So the sunspots are more likely to appear, like strong sunspots. We're talking about, like, the biggest stuff. So they are much more likely to appear at this same spot over a very long duration, like 30 years,
Is there a
something like
name
that.
for it?
Well, they're called active longitudes.
Active longitudes.
Yes, and they are actually 180 degrees against each other. So there's two of them. So they're on the opposite sides of the sun, and they, rotate together.
Where are they
with the
located?
sun.
Where are they antipodes of each other? They're like exact.
Yeah,
opposite?
yeah.
Where are
So
they
they're.
located with respect to the equator?
What do you mean? I mean, they're rotating with the sun.
Well, if they're right on the equator, then they'd be.
Well, I mean, the sunspots, there's this butterfly diagram. So during the rising phase of the cycle, the sunspots appear at higher latitudes, and closer
so
to the maximum,
it's
they rotate.
irrespective of latitudes. It's just.
Yeah.
It's like a stripe on both sides of the sun where you're more likely to have a sunspot all the time.
Sort of. So
What the hell?
you like putting like a vertical, plane through the sun, and where it intersects the sun on the opposite sides, you have these active longitudes. And it seems like there is an interplay between the opposite tools. So that, like, there's what the papers call flip-flop. Not my term.
Well, I mean,
term.
we often
when the activity kind of shifts from one to the other and backwards.
Yeah, we often see a flare that seems to have an opposite side effect, or a CME, same thing.
No, that's not what I mean. I mean the activity is sort of again.
Oh, you mean like a sunspot will form at both sides at the same time?
Yes.
Oh, geez,
no,
that's weird.
Firstly, like at some period, like maybe 5 years, only one of them is more active. Then maybe 5 years later, the other one becomes more active.
Okay.
But it's still kind of the same two spots, and they still rotate with the sun.
Anyway,
so
it doesn't change my theory, which is that there's some kind of solid body inside the sun, which is still.
Yes. That's first
idea.
You
agree with this?
Second idea.
You didn't even tell me before. you're just like, oh, okay.
Wait. But the second idea is that it could be related to some external forcing, because if there are some fixed points on the sun that are more active than anything else on the sun, maybe it's external forcing. Like
by what external stimulus? Then?
Well, I don't know. Dude, like I'm just a researcher. I'm just
okay, Ulysses, I got
some
it.
Hypotheses
and
like trying to test them.
Yeah, I'm not faulting you on it, but I got to ask the questions, otherwise I ain't gonna get the answers.
Yeah, sure. But again, that's the thrill of research, right? You never know what you're gonna find. Like most of the time, actually, and that's a tragedy of the researcher. You don't find anything.
Right. Yeah. So, usually you end up with nothing more than more questions.
Yes, it's very depressing, but initially it's thrilling.
Well, it's an indication that you're doing the science right. It's because you're not researching a bunch of nonsense that everybody else looked up 50 years ago and said that's not how it works. It's not like they're a bunch of idiots. You have to be willing to stand on the shoulders of giants.
Yeah.
If you don't believe them, go read the other papers in the paper that explain why the theory is a valid hypothesis instead of utter nonsense.
Yeah, so it's like a hero's journey. You have a little backpack of all your knowledge, all your skills, like in math, in stats, in physics, in everything. And you just go on a journey. You try to study some subject you have no idea about, and you have a hypothesis, of course, because otherwise you wouldn't even start it. But soon you find it's actually wrong. But maybe you can still find something. So yeah, it's a journey.
Yeah, I mean, it's like the truth is out there. There are probably all sorts of mysteries of the universe that are just sitting there waiting for you to discover in the data. It's just a matter of knowing what data to look at And I mean, I think it's important to have ethics. Once again, sort of bringing us full circle to where we started with the whole thing.
Yeah.
If you're doing science in good faith, this is why I don't mind YouTube comments that make no sense. Now, if it's the same person who's asked me the same thing 18 times in 18 different ways and I've had the same response, one of the ways you can figure out people if somebody is telling the truth is if you ask them the same questions and you keep getting the same answers. It's probably because they're not lying to you. I've had to tell people on the phone this many times, clients, potential clients.
There's this Stasi interrogation technique, the East Germany, basically KGB, secret police. So what they did is they asked a person to basically to figure out whether they're lying, right? So they asked them to describe the events of the evening, let's say, backwards, to check if they, because if you're lying, like you only remember the sequence forwards, right? Like what you should say. Well, firstly we listened to music, then we went to the, store, then we drank some wine. But if you ask them to repeat this backwards, they can't. Like if it's legit, they can do it. But if it's not, they cannot.
It'll work on most noobs.
Yeah.
It's not going to work on everybody, but they have to have their overall program geared to most noobs. It's like the military. People think that everybody who's in the military is elite. It couldn't be farther from the case. It's like gym class. That has to be designed for people that have 100 IQ, not 150 IQ.
Mm-hmm.
Anyway.
Well, anyways, yeah.
Speaking of people with 150 IQ, Eugene thinks his is only like 130, but anyway.
Yeah, I'm 130, around this.
Anyway, I don't care, but it's arbitrary enough that it doesn't really matter. But hey, don't be evil. We got to close this thing out, man. It's over an hour and a half. But
sure.
Again, make sure you go sub over on Eugene the Philosopher. You need to get him to 1,000 subscribers today, or you all die.
And watch
you'll be fine either way. But subscribe to the channel. There's some sweet videos over there. And
watch the Bob Johnson video on plasma cosmology versus electric universe. It's really good. Bob Johnson is really good.
Eugene with Bob, that's got to be some kind of a sexual innuendo. So I'll just leave it there. And if you're in Minsk and you're hot, make sure you go give Eugene a visit also. So we better close this thing out here before I get further into the social media weeds. And but yeah, thanks. Congratulations again on your paper. Look for more videos coming with Eugene in the future. By the way, he's appeared on the channel many times before. He's got to be our top contributor.
Did you see that acknowledgements mentioned you in the paper?
Oh no, you mentioned me in the paper?
Of course I did.
Oh,
I even linked your website.
For real?
Oh, you never read the paper, bro.
I didn't read the acknowledgements.
Why didn't you?
All right, I'll get to, well. It's only been on the preprint server since today.
I know.
Writing. I haven't even showered yet. I just wanted to record this video, so I'll read the paper. Don't worry. And by the way, I won't misrepresent anything and like say stuff about the paper that isn't even true without reading the abstract. That's you can count on me for that, man. That's called scientific chops right there. It's really hard to read an abstract and by the way, in Eugene's his most recent video from the time this was uploaded, he actually talks about how to read a paper, which I loved. He says, look, when you read a paper, here's what you do. Read the title. Maybe take a few moments for that to reflect. And then read the abstract, then read the conclusion. And then if there's anything that doesn't make sense, or if anything that you're particularly interested in the minutia of, then go read the body portion. It's just classic. Maybe Ben Davidson will watch your video. Who knows? I doubt it.
Well, let's not talk about the bad stuff. Let's just end.
Oh, we could talk about the hilarious stuff, though. I mean, hilarious stuff is, dude, there's more content. There's going to be there's going to be lulls.
Let's save it for later, bro. Let's save the good stuff for later.
Yeah, so again, subscribe to Eugene's channel. We'll see you soon with more content. This has been yet another episode. I don't know what number. We don't even number them. It's another episode of The Diamond Anvil, Too Hard to Smash. And I've been your host, Dan, a.k.a. Smash-O-Mash, signing off.
Goodbye.
And may that solar wind be at your back. Back to the bunker. Whoa.